There are a few approaches to this question. I think the fact that I've just got sort of two events and then people doing some of them or not doing some of them makes me feel like drawing a Venn diagram because I've got natural overlap going on. I've got 50 people in total, and I've got people walking and people sailing, and then some that do neither. So I can straight away put that 3 there and deal with that. 18 took part in sailing. So, and then 40 took part in walking. I think I might deal with the walking bit to start with. So I know that I've got 40 people in here, this whole region, but I don't know how many go on the left and how many go on the right. But I do know that that's going to leave me with 10 people. And so this has got to be 7. Basically, I've done 50 minus 40 minus 3. The 50 minus 40 gives me that everything here and here, and I've minus the 3 because I've already got 3 people here. And then the rest of it's all going to work out. So I've got, this must be 11 in the middle, because I've got 18 took part in sailing in total, so I've done 18 minus 7. And then if 40 took part in walking, then it's going to be 29. I've done 14 minus 11. And that's all going to check out now. I've got my Venn diagram. Okay, and that's the hard part of this question, I think, constructing that Venn diagram and realizing that that's an approach that can work because so one of the people who walked is chosen at random. Find the probability that this person also sailed. Okay, so we're not quite at this is still a bit tricky because now we're told that we're only asked about the people who walked, so it's sort of a given that they walked kind of thing. So I can ignore these people; they're gone. Find the probability that they also sailed. Well, 11 also sailed, and that there were 40 of them in total. So it's going to be 11 over 40. Now, that's one approach. I'm just going to quickly talk about another approach, and that is a two-way table, because you could have them walking and not walking along one column, and then sailing or not sailing along the other. And this is an effective approach as well. And then I'll have the total here and the total here, and I can fill this in. So I've got the 40 took part in walking, that's going to go here. I've got 18 took part in sailing. You might think this is a more, an easier thing to fill in. You might not. And 3 did neither activity, so that's going to be here. And then I've got 50 people in total. Now it's a case of filling in all the gaps. This has got to be 50 minus 18, which is 32. And this has got to be 29 because it's 32 minus 3. Then this has got to be 11 because it's 40 minus 29. This has got to be 7, I'm just filling in, and then this has got to be 10, and that all checks out as well. And then if I want to work out the probability, so I'm just looking at the people who walked, the probability they also sailed. So I can basically now ignore all of this because I'm only interested in people who walked. And then again, it's going to be 11 people sailed out of the 40 in total, and that will give me the same answer. So, maybe you prefer this option, maybe, but both approaches will work. There is also the case for drawing a frequency tree. I'm not going to go through this in detail now, but you could look at actually, I don't know if the frequency tree would work as well here. Sailing, so you've got sailing, and then you've got walking and not walking. Yeah, that would work. Or not sailing and walking, or not walking. And you could fill in like the numbers that do each of these. That's another approach. I'm not going to go into detail here because I've already talked about 2 approaches, but basically find an approach for realizing this information, like sorting this information, realize it's a conditional probability question, and get the answer.